Hello, Mr. Kevin.
Hello, Leila and Elmira.
Hi, Mr. Qasim.
Hello. Okay. Elmira, Leila, how are you? Are you okay?
Not
Did you have time to practice questions from... Leila, did I actually share this paper with you? This 2016 P6. Okay. Elmira, Leila, are you ready for class?
yes.
Today we are going to practice questions from 2016 P6, okay? And after that, I will share with you this 2017 P5 and P6. If you have time, try to practice these questions at weekend, okay, Saturday and Sunday. And if you come to the next class prepared, we will go much faster. We have only 3 hours left, okay? And as you know, your exam is on, I think, April 27th. Okay. So now last time we did 2015, and usually P5 and P6 questions, they are similar, but P6 is a little bit harder. Okay, so at least now you have some idea how to solve these problems. Question one, Almira, let's continue, okay? Maybe 1 to 3 questions. You can do that together, and after that, I will give you some time. First, you try, and after that, we will discuss the solution. Can you read the question, Almira?
Of course. Suppose it's now the month of December. What month will be 100 calendar months from now?
Did we do this question last time? Do you remember?
I think now.
Hmm? No? Okay, anyway.
I
Well,
think
what do you
now.
think, Almira? Just tell me the idea. How do we solve this question?
Just I will divide 100 into uh, 12.
Very good. Very good. So we know that actually in 1 year we have 12 months, right? And after 96 months, it will be full 8 years, right? So after that, again, actually the same thing repeats, and the 4 means remaining 4 months. Since now we are in December, so actually what is it? What month will it be? 100th calendar month from now, it will be, what is the fourth month after December? If you count this, January, February, March, April, right? Fourth month will be April. Okay. Leila, can you read the next question?
Yes, 6 machines can produce 15 items every 30 minutes. How many additional machines are needed to produce 70 items every hour?
6 machines can produce 15 items every 30 minutes. How many additional machines are needed to produce 70 items? Let's also do this together, okay, as an introduction. After that, one more question. Then you will try to solve questions after question 5. So it says that we are talking about machines. Here we have machines and the produce items every 30 minutes. Let's say produce items. And here we have time. Okay, so we have machines, items, and the time. So 6 machines, right here we have 6 machines can produce 15 items in every 30 minutes. How many additional, it's not asking how many machines, how many additional, right? Machines are needed to produce 70 items every hour. So Elmira saying D. Are you sure, Elmira?
I think yes.
Okay, let's see. I think again, Elmira, did you pay attention to this additional?
Yes, yes.
So is your answer 14 or 20?
14.
If it is 14, the answer should be 8, right?
No, they're 20.
Oh,
And I
20.
minus 6. I get and
Okay,
get
okay. Let's see then. So, all right, how many additional machines are needed to produce, let's say how many machines to produce 70 items every hour. Every hour means 60 minutes. Now from here, first, let me just increase this one, okay? If we have 6 machines to produce actually in 60 minutes, right, it can produce 30 items. Because 6 machines, if they work more, they can produce more. So here we have 60. So actually it should be 70, right? Okay, now we have 60. I'll just fix this. Now, how about if we have more machines, they can produce more items in 1 hour. If we have less machines, they produce less items in 1 hour. So how can I have 70 here? To do this one, actually, if I have more machines, more items, if I increase the number of machines, also I need to increase the number of items. So here I just multiply by, what is it? Here we have 30. I want to have here 70, right? So 70 over 30. Time is not changing here. And also I multiply this by 70 over 30. Now from here, if you simplify this, they cancel each other. 6 over 3, it's 2 times 7, 7, that's equal to 14. Now 30, 30 cancel each other. Here it is 70. So here we have 60. But here, Almira, we need actually 14 machines to produce 70 items in 60 minutes, which is 1 hour, right? So the answer is, it says how many additional, that is 14. At the beginning, we had 6 machines. We had 8 additional machines, not 20, 14. New one in the fridge. Okay, Elmira. Did you see your mistake, Elmira?
Okay. But when I divided 17 to 5, I get another answer.
I mean, did you see your mistake
I
or
just made
still
mistake.
you are not sure?
Yes, yes. Now I'm sure.
Okay. All right, next question. Elmira, read the question.
How many of 17 all numbers must be odd of if their product is odd?
How many of 17 whole numbers must be odd if their product is odd? Leila, did you understand the question?
Maybe yes.
How many of 17 whole numbers? We know whole numbers, right? When you just say whole numbers, we mean these numbers, that is 0, 1, 2, 3, these numbers. And what we mean by odd, we know that we have odd numbers, we have even numbers, right? Odd numbers are 1, 3, 5, 7, dot, dot. And how about even numbers? There's 0, 2, 4, 6. These are even numbers. Even numbers means when you divide by 2, the remainder is 0. Odd means when you divide by 2, remainder is 1. Here the question is asking that if you just pick any 17 whole numbers, when you multiply them, their product is odd. If it is so, how many of these numbers are odd? Any answer, Elmira, Leila?
Mm,
Minute, please, minute.
How many?
I found the answer, but minute I have to count them.
Oh, you don't have the count. Just you need to know that, Elmira, here, if you multiply even number by odd number, what is the result? It's even or odd?
Even
It is even, right? Because, like, for example, I said 2 is even number. Multiply by odd number, 3. 6. 6 is an even number. If you multiply even number by odd number, it's always even. And how about if you multiply even number by even number, is also always even number, right? So if you multiply odd number by odd number, it's always odd number. So that means that out of the 17 numbers, even one of them is even and others are odd, the result will be even. So that means that none of these numbers can be even number. If the result is odd number, if the result is odd number, all of them must be odd number. Because otherwise, even one of them is even number, multiply even number by odd number or even number, the result is even number. That's why all of them must be odd numbers. So how many of 17 whole numbers must be odd? If the product is odd, all of them must be odd. Even one of them is even, and even times odd times odd times odd, 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 the result is even. Because even times any number is always even. I mean, any whole number. Okay, Leila, did you
yes,
understand?
mm, now yes.
Good. Next question. Elmira, read the question a bit louder, please.
in the magic show, the magician placed four cards on the table
Magician, the
as shown
magician,
below.
the magician placed.
The magician placed four cards on the table as shown below. Each card has a mass symbol on one side and a number on the other side. After showing the cards, he flipped over some, maybe all of the cards, and rearranged them. The new arrangement of the cards is shown below. How many of these four cards have an even number on one side?
How many of these four cards have an even number on one side? Usually, okay, if I give you some time, okay, let me give you 1 minute, okay? Try this, and after that, we will do it. It's a very easy question. Leila, did you get anything?
Yes, what I will say.
How many?
Maybe yes.
Louder, please. I cannot hear you, Leila.
I don't know. Now I can say.
Elmira, how about you?
I think mid D three.
Good. Because we are talking about four cars, right? And every car has two sides. It is front and back, right? So these are four cars. And let's say these are front side. And these are back of these cars. Let me draw a bit smaller. So it says that each card has a math symbol on one side and a number on the other side. So if you just look at the top right, how many mathematical symbols we have used? It is addition and division. So here we have, let's say this one is addition and division. In the second, actually, was this group of cards, here we have multiplication and subtraction. That means that these cards must have this, what is it? Multiplication and subtraction. So as you see here in the second line, right, addition and division is not used, which means that at the back of this addition and division, it must be 5 and the 4. But the order is not important. So it must be 5 and it must be 4. In the second one, here multiplication and minus, right? So at the back of this multiplication and minus, it must be, what is it, 6 and 4. So out of these cards, as you see here, we have how many even numbers? 4 is even, 6 is even, 4 is even. Because in the question is asking, they're not asking how many even numbers. It's asking how many of these 4 cards, right, have an even number on one side. So 3 of the cards have an even number on one side. Okay, good. Let's move to the next question. Leila, read the question.
Find the largest value of n in if the number two, um,
201
2000,
M6.
2006 is divisible by 9.
Find the largest value of m if the number 201 m6 is divisible by 6. What numbers are divisible by 6, Leila?
This is number 2 can be divisible by 7 and 6.
If the sum of the digits, right, is divisible by 9, those numbers are divisible by 9. So that is 2 plus 0 plus 1 plus m plus 6. This should be divisible by 9. And if you just simplify this, 2 plus 0 plus 1 is 3, 3 plus 6 is, it is 9 plus m. So when this one is divisible by 9, if m is equal to 0 or m is equal to 9, right? M equals 0, that will be 9. If m equals 9, it will be 18. Both numbers are divisible by 9. That's why the 5-digit number will be divisible by 9. But in the question, it's asking, find the largest value of m, right? So which of the value is, which one is the largest? It is 9. So the answer should be 9. Now, next question is for you. Okay, I will give you, what is it, 1.5 minutes. First, Elmira, can you read the question?
Yes. Bianca and Jordan went to a market to buy some food. Bianca paid $29 for muffins and 3 pies. Jordan paid $31 for 5 muffins and 2 pies. What was the price of a muffin?
Good. Girls, you have 90 seconds. First, give it a try, then we will do it together. You want to drink it? Yeah. You would 12. You play too much. Okay, okay, only 30 minutes. Good. Elmira, that's correct. Leila, how about you? Did you get anything?
The eight.
So let's say the price of one muffin is M and the price of one pie is P. At the time, if you buy four muffins and the three pies, right? It is $29. And how about if you buy five muffins and the two pies? That is, what is it? $31, right? So usually, how do we solve this? What is it? Two equations. One good way is we have to eliminate. In equations, you know that if you multiply both sides by the same number, it does not change, right? I will multiply the first number by the first equation by 2, the second equation by 3. Why? Because I'm going to eliminate this p from the equations. So if you multiply both sides of the first equation by 2, 2 times 4 it is 8, m 2 times 3 it is 6, p 2 times 29 it is 58. The second one by 3 it is 15 m, and the 4p is equal to 62. It is not 4, it is 6, right? We are multiplying by 3. And also multiply by 3. 3 times 31 is, it is 93. So now if you subtract the first equation from the second one, 15m minus 8m, that's equal to 7m. 6p minus 6p is equal to 0. 93 minus 58, that's equal to 35. Is it?
Yes, it's 35.
Okay. So m is equal to 35 over 7. That's equal to 5. So which is the price of one muffin, right? So the price of one muffin is $5. Okay, another way is just guess and trial method. Okay, can you just write 29 as 4 times a number and 3 times a number, and 5 times a number? And if you just check this, for example, 4 times 5, 5 times 5, 3 times 2, I mean 3 times 3, 2 times 3, it works. Another way is just you have to substitute the answers and check this, does it work or not? But this one is how to get the exact solution. Anyway, let's move to the next question. Leila, read the question a bit louder, please.
It is given that A star B um, A multiplied by A plus B for any whole numbers A and B. For example, 2 star 3, um, 2, or 2 multiplied by 2 plus 3, uh, 7. What is the value of A given that C star 7 and 5 stars 8?
Leila, did you understand the question?
Mm, yes.
It's saying that A star B. What does it mean? It means that multiply A by itself and add B to the result, right? If it is so, in this equation, what is the value of capital A? Elmira, you already got the answer. Let's do this together, Leila. Okay, we'll go a bit faster. So according to this rule, then A star B, which means on the left-hand side, that is 6 times 6 plus 7. And how about on the right-hand side, we have 5 times 5, because we need to multiply the first number by itself and add the second number. So 6 times 6, 36, plus 7, that's equal to 43. And take 25 to the left-hand side, minus 25, and that's equal to A. What is A? A equals 43 minus 25, that's equal to 18. So the answer is 18. All right, next question. Elmira, read the question.
Daniel cut a paper into half. Then he cut the papers to produce half of each of the pieces of paper. He repeated this many times until he got more than 1,000 pieces of paper. What was the least number of cuts he made?
What was the least number of cuts he made, right? And suppose that, for example, if I just give you a piece of paper, how do you cut this into smaller pieces? Just try to answer this question, and after that, think about this problem, okay? You have 1 minute and 30 seconds. Leila, Elmira, both of your answers are not correct. Leila, why is your answer A?
Because we can, how can I say, we can, how can I say, make this. And cards, it's be made. Wait, okay. I
Very
don't
good,
know.
very good. If it is so, why is your answer 499, Leila? Why?
Because when we cut, we can make, how can I say, this.
You are saying that, okay, you just take the paper, all right, if you can see the paper. Uh, okay, cut into two, right? Into two, right? Now we have two. Now join them together, put them together. Now cut this. How many pieces do we have here? Now, in two cuts, we have 4 pieces. And if you cut one more, for example, I have how many? 8. You see, it is increasing a lot. Now, suppose that here, we are talking about this kind of big paper, right? Okay. Now you cut from here. This is my first cut. How many pieces I have here now? 2. Now you cut here, all right? Now you see here this one, 1, 1, 1, 1. Now I put them together, okay? Just take them together. This is my first cut, and this is my second cut, right? Now put them together. Now I have smaller pieces. So I have 4 papers here. Now if we cut here, and if you cut here, right? So I have 4, I have 4 here, 4 here, 4 here. So how many here? I have 16 now. Third cut, and number 4. Now I have smaller one, and again cut them from here and cut them from here. Each one I have here 16, I have 16, I have 16 and 16. So this is number 5 and this number 6. So I will continue. Now I have smaller one, again cut from here and cut from here. I have here 64, 64, 64, 64. So now again, if you just put them together and cut it, from here and from here, right? 4 times 64, I have here 256, 256, 256, 256. Now I have already more than 1,000, right? How many? I have 1,024. How many cuts we made here? 5, this one is 7, this one is 8, this one is 9, and this one is 10. If I just cut 10 times, right, I can make more than 1,000 smaller pieces. And Mira, did you understand?
I understand, but not at all. Like,
So
I
we don't
understand it.
just we have 10 with 10 cuts, I can cut one piece of paper into more than 1,000 smaller pieces. Just 10 cuts. So here we don't have any answer, none of the above. You can just try yourself, okay? You will see that after, as you see here, fifth cut, you have a lot of pieces. And seventh cut, you already have, it's more than 200 pieces. When you just make 10 cuts, now you already have how many? It is 1,000 pieces. So none of the above. All right, let's move to the next question. Leila, why is your microphone not good? When you read, I cannot hear you well.
I don't know.
Who knows?
Maybe mm,
Because when
sometime.
you read this, I cannot hear you well or I don't understand. Anyway, Leila, read question 9.
Daniel participated a chess tournament. There was 10 players in the tournament. Each player um, played, played once with every other player. A player received 2 points for a win, 1 point for a draw, and 1 point for a loss. What is the sum score of all players?
Okay, we are talking about a chess tournament. There were 10 players in the tournament. Each player played once with every other player. A player received 2 points for a win, 1 point for a draw, and 0 points for a loss. What is the sum of the scores of all players? First step, you need to find the total number of games played, the total number of games, and after that, for each game, what is the total score given? And after that, you will get the answer. Okay, let's do it. Abbas, garbage. And also take those stuff. Elmira, what did you get?
I get nine. I got 19.
90.
Yes.
Leila, how about you? Very good. Leila, did you get anything?
Yes, I did anything but my answer is no up there.
What? Say again?
My answer I don't know. 1 minute.
Okay, Leila, let's do it together, okay? So maybe actually when you have time, you need to solve them once again. At that time, you understand more, and also it will help you to how to say consolidate your knowledge. The first, we need to find the total number of games played, right? And we know that if you're talking about 10 players and they actually play once with every other player, the first guy plays against 9 people, right? So the total number of games, let's say this G, it is 9 plus 8 plus 7 plus 6 plus dot dot, and here it is 3 plus 2 plus 1. What is it? It's just the sum of the first 9 natural numbers. If you remember, how do you find this sum? It's just equal to 9 times 10 over 2, n times n plus 1 over 2. So that's equal to 45. That means that in this tournament, 45 games are played. Now, again, the second one is if you just make a very short observation, we know that, for example, if a guy wins
Answer,
and loses, right?
this
Let's say,
second
yes,
answer is B. My answer is B.
Leila, what did it say?
My answer is a B. B.
B?
Mariam B. Yes.
B.
Yes.
How did you get B?
Um, I am uh, 45 divide or multiply it for 2 to be 9 and plus 10 because when the 10 players lose, let me see, uh, uh,
Hmm.
he, these players play again. I don't know.
Hmm. Okay, Leila, actually the answer is 90. So here we have 90 players played. Suppose that we have player 1 and player 2. Okay. Now, if the first player wins, right, he gets 2 points. The second, all right, player 1, if player 1 wins, he get 2 points, and player 2, that means he loses, got 0 point. So what is the total score? It is 2, because 2 plus 0, it is 2. If it is draw, each player gets 1 point, right? Again, the sum of the points is 2. If the first player loses, second player wins, and at the time, again, still the total score for each game is 2. So how many games are played? 45. For each game, 2 points is given. So altogether, I mean, in total, 90 points are given to the games, I mean, to this tournament. Okay, let's move to the next question. How many squares are there in the figure? Now, Elmira, Leila, we know that in every Sasmo paper, okay, contest, there is one similar question. So you have to understand this well, how to find it, okay? You need to count this in a systematic way. So since we are talking about squares, you'll count, okay, 1 by 1 squares, and 2 by 2 squares, and 3 by 3 squares, and 4 by 4 squares. And after that, just add them up, okay? So you have 2 minutes, or okay, 1.5 minutes. 2 is too much. Start now. Ah, ah, go bring pillow for yourself. Elmira, C. Really?
Yes.
Leila, how about you? How many did you find? Okay. One by one, if you can hear, one, two, three, four, five, six,
It's a
seven,
cat.
eight, nine. So it is
Nine
nine.
is
Yes, Leila.
is
Can you write
yes.
your answer, Leila? I really cannot hear
Yes.
you. You know your voice. I don't know your microphone or. Leila says A, 15. Okay, Leila. I think Leila, your answer is not correct. Okay. All right. So now one by one square we have nine. And how about two by two squares? Now here we have two by two squared, number one, and this one is number two, and number three, and number four, and number five, right? Anything? No. So we have five. What is it? Two by two squares. Yes, I think that's all. Five. And how about a three by three? Three by three is this one is big one, right? Three by three, and that's it. I think that's all. One. And how about four by four? The biggest one is it is one. So altogether, how many? 14, 15. It is 16.
You still
Elmira,
can.
how did you get 17?
You still can. No.
Just I mm, when I plus it, I have a mistake. I get like the same as you.
16?
No, 17. But I find my mistake.
Okay, it's
Make
16, right?
mistake.
When I yes, yes.
Good. Okay, Leila. Here we have 16 squares. Elmira, Leila, we practice a lot of questions, girls. You should not make this kind of mistake anymore. Because you know how to count us. You need to be careful. That's it. It's not the first time we are solving this kind of questions, right? Okay, let's continue. Next question. Elmira, read the question.
The year 2016 is an interesting number because it's divisible by 1, 2, 3, 4, 6, 7, 8, and 9. One is the next year that has the same properties as above.
What is the next year that has the same properties, right? Properties means they follow the same rule, right? As above. Just tell me the idea, Elmira. What do you think? How do you solve this question? I mean, the first step, what do
Just
you do?
I will this divisible by 9.
Well, actually,
Then
to
I will
answer this
look.
question, first we have to find the least common multiple of these numbers. So actually, what numbers they have the same property with this? Actually, what is it? Which of the following has the same property with 2016? All the multiples of two. What is it? All the multiples of the least common multiple of these numbers have the same properties. So if you find the least common multiple of these numbers, right? That's actually I don't have to write one, two, three, four, six, seven, eight, and 9, right? And how do you find this? We should divide by prime numbers, right? 1, here it is 3, it is 2, 3, 7, 4, 9. So we have even number. I can divide by 2. It is 3, 1, 3, 7, 2, 9. Still, I have even number. Divide by 2 one more time. 3, 3, 7, 1, 9. We don't have any even number. Next prime number is 3. Divide by 3. It is 1, 1, 7, 3. Divide by 3. It is 7, 1. Now divide by 7, 1. So the product of these numbers gives us least common multiple of these numbers. So least common multiple of those numbers is equal to 8 times 3 times 3. It is 9 times 7. That's equal to 504. So that means that what numbers have the same property that's divisible by all of these numbers? Those numbers are 504, 1008, because 2 times 504, 3 times 504, that is 1512, multiplied by 4, 2016, multiplied by 5, 2520 continues. So now it is this year, right? Because this exam was in 2016. That's why next year, which has the same property, is 2520. That is, of course, it's a general solution. And also looking at the answer, Elmira, Leila, we can get the answer, right? First, the smallest number here after 2016, that is 2520. And check this, is it divisible by all of these numbers or not? If yes, then that is the answer. That's another way of solving this problem. Okay, Elmira, Leila, do you have any questions about this problem?
No.
Okay, let's move to the next question. Find the next fraction in the sequence below. 90 seconds. Put it down on the floor. Open it. You can close it later. First. Leila, did you get anything?
I see. No, I don't know. Maybe I don't know.
Elmira, how about you?
No.
Look, girls, in this kind of fractions, one way is, okay, uh, bring into the common denominator. Or, for example, here the first fraction is 3 over 4, right? And the second one, if you multiply by 4, what happens here? 4 times 2, it is 8, right? 1 over 2 is the same as 4 over 8. Why is it so? Because here, I'm expecting that it's 4 and 12 and 20. These are multiples of 4. If 4, the next multiple of 4 is 8. And here we have 5 over 12. Now, how about this one? Multiply by 2. I mean, numerator and denominator multiply by 2. 2 times 3, it is 6. 2 times 8, it is 16. And next one is 7 over 20. Now, what do you notice here? Here we have 4, 8, 12, 16, 20. Next fraction, it must be 24. I mean, denominator of the next fraction. Now, if you look at the numerators, 3, 4, 5, 6, 7. So the next fraction's numerator must be 8 over 24. But we know that actually you studied equivalent fractions, right? If you're given a fraction, if you multiply or divide its numerator by the same number, the value of the fraction does not change. So 8 is 8 times 1, 24 is 8 times 3. So that is equivalent to this fraction. So the next term of the sequence is 1 over 3. Okay, good. Next question. Let's try to finish this. How many times do the hour hand and minute hand form 90 degrees from 2 p.m. to 10 p.m.? Girls, let's do this together, okay? Because if I give you time and do this again, it takes a lot of time. Now we are running out of time, so what we have to do is we know that when we just say that 90 degrees, right? 90 degrees, we mean this kind of situation. Here we have maybe hour hand or minute hand, okay? They are in this position. So the angle between them, it is 90 degrees. And we have a lot of different cases, right? Maybe it may be like this also, another way, right? And also they form 90 degrees. So now in the question, it says that between 2 p.m. and 10 p.m. Okay, so now I start from here, from let's say 2 to 3 o'clock. Let me just write here. Otherwise, we cannot find it. For we need to write one by one. From 2 to 2:59. All right. And after that, 3 to 3:59. And 4 o'clock to 4:59. And 5 o'clock to 5:59. And 6 to 6:59 until 10, right? It is 7 to 7:59, and here we have 8 to 8:59, and here we have 9 to, what is it, 10 p.m. That's it. So now we have to find actually between these hours how many times do it forms 90 degree, right? For example, if I ask you the question first, Elmira, between 2 o'clock and 2:59, how many times do the hour hand and minute hand form 90 degrees? So immediately you should draw a clock, right? I will draw this later
8.
maybe. How many times?
8.
No, only one. Because here, look, here, this one is 2 o'clock right now. And this one is 2 o'clock. Here we have 1 and this one is 2. So this one is 2 o'clock. And this angle is smaller than 90 degrees. So now this hour hand, minute hand, it is moving down, right? It is moving down. So after some time, it just comes to here, right? It comes to here, maybe, I don't know where it comes. And also our hand comes here. So now they form 90 degrees. Only one time. If you have a clock, you can just move this, okay? How many times? You will see that only one time. It forms 90 degrees only one time. And after that, if you look at the second part, for example, when it is 3 o'clock, it's already 90 degrees, right? 3 o'clock means it is here, minute hand, and this one is 3 o'clock. So it's already 90 minutes. Now, again, this minute hand is moving, the angle is getting smaller, and after getting bigger. So again, after some time, right, it forms again. So how many times? It forms 2 times. And how about from 4 to 4:59? If you look at this one, it is 4 o'clock. Here it is, this one is 3, right? 4 o'clock is somewhere here. So this one is 12, right? Now this angle is more than 90 degrees. When a minute hand moves a little bit down, it forms 90 degrees. And it passes over the hour hand, again it forms another time. So again here it forms 2 times. For 5 also, again it is 2 times. And between 6 and 6:59, also it is 2 times. And 7 to 7:59, again, it is 2 times. But how about 8 to 8:59? If you look at this 8, for example, here we have, this one is 8, okay? And this angle is, what is it? It is not 90 degrees, more than 90 degrees. It is moving down. Here it comes somewhere. Here it forms 90 degrees. And when it is 9 o'clock, it forms here. But we are talking about until 8:59. So it forms only one time. When it is 9 o'clock, right, it is here, 9 o'clock is here, and 9 o'clock is here. That is the first 90 degrees, and it is just moving down, comes somewhere here. Again, it forms another 90 degrees. So it is 2 times. Altogether, how many? How many twos here? We have 1, 2, 3, 4, 5, 6, 12, and 2 ones. It is 14 times. Okay, and this is how we solve this problem. If you have a clock, you can just practice it, to really understand this problem. Okay, so guys, I will stop here. All right, we will continue from here next time because now I have another class. I need to have some rest. And if you have time, try to practice. Let me just check the WhatsApp. Elmira, you are in WhatsApp group, right?
Yes.
Leila, how about you? You also in WhatsApp group?
Yes, yes, yes.
Good. Maybe I will send you the questions there. Okay, try to practice until next Monday. If you can solve, practice. Okay, if you don't have time, at least have a look at the questions. Okay, first read and understand, and also it helps us to go much faster. Okay, girls, thank you very much. Have a
Okay.
nice weekend.
Thank
I
you
will see
too.
you next Monday. Okay, all right. Bye bye.
Bye bye.
Bye bye.
Thanks.
Thank you.